Hi, my name is Josh Udy. I'm the Elementary Mathematics Curriculum Manager for Houston Independent School District. Today, I'll be solving a problem from the new HISD problem-solving journals. While solving the problem, I'm going to be using the Mathematics Problem-Solving Board. Let's go ahead and start by reading the problem. Coach Carter timed some students during a swim meet. The students' times for the 50-yard medley are listed in the table below. Student, race time. Lorraine, 6 and 25/100 minutes. Robert, 7 and 18/100 minutes. Yanira, 6 and 17/100 minutes. Leon, 7 and 8/10 minutes. Kim, 6 and 25/100 minutes. Pamela, 7 and 9/100 minutes. Lorraine, Robert, and Pamela were on the green team. Yanira, Leon, and Kim were on the yellow team. The team with the lowest total time won the race. Which team won, and how much faster were they than the other team? To begin starting this problem, we will actually rephrase the question in our own words. I know that the question asks which team won and how much faster were they than the other team. So I'll want to write the blank team won. They were blank minutes faster than the other team. By rephrasing the question in my own words, I'm ready to start solving the problem because I know exactly what I'm looking for. I'm looking for which team won and how many blank minutes faster were they than the other team. So let's move on to analyzing the information. When I read this problem, I saw that there were two teams. I know that there's the green team and the yellow team. I want to know together which team was the fastest. And that means that they have the lowest total time. I also need to know how much faster they were than the other team. So, how much faster? I think I've pretty much analyzed the information from the problem. I know that there's two teams, the green team, the yellow team. I'm trying to figure out which team was faster with the total time, meaning when you're faster, you have the lowest time. And I want to know how much faster were they than the other team. This means I'm ready to formulate my plan or strategy of action. There's a couple of steps I need to take in order to do this. One, I need to add up the team's times. So I'm going to add the green team, green team's time, and I'm going to add the yellow team. Now, after I've added the two teams' times, I actually am going to want to see which time is lowest. This makes sense. After I figure out which team's time is lowest, I'll know which team won, and then I'm going to have to, number 4, subtract, because I need to figure out how much faster they were than the other team. So how much faster? Let's go ahead and do these steps to determine a solution. First step was determine the green team's time. Just to be fun, I'm gonna write green team with my color green because that's gonna help me remember. Lorraine, Robert, and Pamela were on the green team. Lorraine was 6 and 25/100 minutes. Robert was 7 and 18/100 minutes. Pamela was 7 and 9/100 minutes. My first step was to add up the green team's time. I'm going to use the standard algorithm to do this. 9 and 8 is 17. 17 and 5 more, 22. 2 and 2, 4, 5. 6, 7, 13, plus 7, 20. 20 and 52 hundredths minutes. That's the green team's total time. I now need to add up, for my second step, the yellow team's time. I'm gonna write yellow team, but then I'm gonna use a black marker because I don't know if I can even see that myself. So on the yellow team, we had Yanira, 6 and 17 hundredths minutes, Leon, 7 and 8 tenths minutes, and Kim, 6 and 25 hundredths minutes. In order to add this, I'm going to annex a 0 here and write that number as 7 and 80 hundredths. 7 hundredths and 5 hundredths is 12 hundredths. Regroup there my 1 tenth, 1 tenth, 2 tenths, and 8 tenths, 10 tenths, 12 tenths. Regroup my 1 whole. 6 and 7, 13, 14, and 6, 20 and 22 hundredths minutes. These times were very close. The next step was to see which time is lowest. This means that's the team that was faster. They were just barely faster, but the yellow team had a lower time. When I'm comparing these two numbers, I see that 20 and 20 is the same, the value in the whole place. But here, this team took 5 tenths minutes, while this team only took 2 tenths minutes. So I know that this is the lower time. Now I want to subtract to see how much faster were they. So the green team was 20 and 52 hundredths. Subtract 20 and 22 hundredths. 2 subtract 2 for the hundredths. 5 tenths minus 2 tenths is 3 tenths. They were 30 hundredths or 3 tenths minutes faster. 3 tenths minutes faster. So that's my solution. I probably should write that out. Which team was faster? I need to go back to the original sentences that I wrote at the beginning. Remember, we rephrased the question in our own words. This will help me as I try to answer the question. The blank team won. The yellow team won. They were blank minutes faster than the other team. They were 3 tenths minutes faster than the other team, or 30 hundredths minutes faster. Okay, now that I have my answer in sentence form, I'm ready to justify my solution. I'm gonna look at my work again to make sure I followed all of my steps. The green team, I added up those 3 times. The yellow team, I added up those 3 times. It would be very advantageous for me to actually look and make sure that I wrote down every one of those times correctly. 6 and 25 hundredths, 7 and 18ths, 7 and 9 hundredths for Pamela. This was Lorraine, this was Robert, this was Pamela. I added up the 3 times correctly. For the yellow team, 6 and 17, this was Yanira. 7 and 8 tenths, this was Leon, and Kim, 6 and 25 hundredths. So as long as I did my math correct, I should be okay. We'll check that in a second. Justify the solution. How can I prove that my answer is correct? Well, I can do a couple of things because we're dealing with addition and subtraction. One thing that I can do is I can take the winning time, which was the yellow team. I know that they had 20 and 22 hundredths minutes, and I can add 3 tenths minutes to that. This should equal to the green team's time because I'm saying that the yellow team was 3 tenths minutes faster than the green team. So I add this up, annex my 0 in the hundredths place, 2 hundredths, 5 tenths, and 20. That is the green team's time. So I know that I have justified in a way because I took my yellow team's time and I added the difference, and that should give me the green team's time. This means we're ready to move to the next section of the board. Evaluate the problem-solving process. When I'm thinking about evaluating the problem-solving process, let me first clarify, I'm not talking about evaluating my solution or evaluating the problem. I'm talking about evaluating how I solved the problem. I'm actually going to be thinking about the process that I used. there's three questions you could really ask yourself. One, was the way that I solved the problem efficient? Is there an easier way to solve the problem? Number two, and how does my work compare to the work of others? One great tool to use in the classroom is to allow students to compare work one with another. This gives them an opportunity to truly evaluate their problem-solving process in a way that they may not have thought about by looking at their friends' work. We know the way that I solved it, but let's take a look at how two other people solved it. I asked a friend to solve this question before solving it myself. This is what she came up with. Her steps: add the green team time, add the yellow team times, who's faster, subtract the teams. When I look at her actual work though, I see something very different from what I did. She's drawn a pictorial representation of the time that the team spent. Using the flat as a whole, I see that she's drawn 20 here for the green team, and then she's drawn longs to represent the tenths, and small little dots to represent the hundreds. She does this for both the green team and the yellow team, and then there's this process of comparison that I can see in her work. She's done a dot here, a dot here, a dot here, a dot here. I assume that she's comparing the two amounts, figuring out how much more the one team had than the other. And I see she does do a little bit of standard algorithm work off to the side. We ended up with the same answer. So I ask myself, how can I evaluate my problem-solving process compared to this problem-solving process? Well, first, she has a conceptual understanding of decimals. She drew it all out. She knew what she was dealing with. She had flats representing the wholes, longs as tenths, dots as hundredths. But was this very efficient? Certainly, my way was more efficient if I know how to use the standard algorithm, because I didn't have to draw all of these pictures. Her way is a great way to justify though. If I wanted to justify my solution using a pictorial representation of base 10 blocks, this would be a great way to justify my solution with another process. Let's go ahead and look at another way that someone solved this problem. I have a friend who solved here. He wrote add green, add yellow, subtract teams. And now I see numbers all over the place, so let's take a minute to figure out what he's done. Adding the green team times, he wrote them sideways. Then I noticed that he took each of the whole numbers, 6, 7, and 7, and added those up first to get 20. It looks like this student has decomposed. Then he takes each of the decimal parts, 2500ths, 1800ths, and 900ths, and adds that up off to the side. I see then that he takes the 20 as the whole and adds it to the decimal part to get 20 and 5200ths. That's for the green team. For the yellow team, I notice again, whole numbers first, 6, 7, and 6 to get 19, and then he adds up 17, 8000ths, and 2500ths and gets 1 and 22. Again, decomposes 1 and 19 is 20, and then now he has 20 and the 2200ths from this part to get 20 and 2200ths. Now he's going to subtract 20 is 0, and he then takes the decimal parts. 5200ths minus 2200ths is equal to 3000ths. A correct solution, and a little bit, I would say, in between the standard algorithm, what I did, and a pictorial model. This student has a strong grasp of number sense because he's decomposing the numbers by place value, adding up all the whole numbers, then adding up all the decimals. I don't know that it's more efficient than my way, but I like this strategy a lot. It shows that this student has a strong grasp on the problem-solving process and understands what's going on. I might be a little bit afraid, though, that you could make a mistake somewhere in here and not be able to retrack and figure out what you did. Now that I've looked at these three different ways to solve the problem, I looked at my own way, I looked at my friend's way with the base 10 pictorial blocks, and I looked at my friend that did decomposition of number. I need to evaluate the problem-solving process. What do I write in this square? This is a great question. Was it an efficient way to solve the problem? So I'm going to say I used the standard algorithm. Was this efficient? My way was efficient because I had fewer steps. Or I didn't have, but I took fewer steps. to reach a correct solution. How does my work compare to the work of others? My answer was the same as my friends, My answer was the same as my friends, but is that evaluating the process? Not really. What else can I say here about how my work with the standard algorithm compares to my friends? But my friends showed pictorial models and decomposed. This took them longer to get the right answer. I think I'm pretty satisfied that the way I solved this problem was a fast and efficient way to solve the problem. Going back and thinking about what I wrote down for my justify the answer, I'm actually now thinking about my friend strategies, and I'm realizing maybe what I put down for justify the solution wasn't as good as it could have been. Could I justify the solution with some of their strategies? So when I come back and look at this section of the board, now that I've compared to my friends, I come back to the justify and I say, well, yeah, I added it up, but the way they solved the problem was so much more elaborate. They decomposed their numbers or they used pictorial representations. So it might speak to the fact that I need a little bit more help here with justifying my solution. Certainly I could use some of my friends' strategies to prove my own answer. I could have pulled out base 10 blocks or used a pictorial representation to build these numbers to justify that my answer using the standard algorithm was correct. So I learned a little bit there from evaluating the problem-solving process of my friends. I'm going to move to the final section of the board, which is, how do I know if the answer is reasonable? Well, I don't think I did anything to even think about reasonableness. Back when I analyzed the information to the problem, I didn't estimate. It didn't even cross my mind to maybe just check to see how I could make the numbers more compatible or something to add it up. So how do I know that my answer is reasonable? There's a couple of ways to think about this. One, I could have estimated to begin, and then I could compare my answer back to the estimate. Or two, I can think about times in real life. Certainly I know if there's two swim teams doing a race medley of different events, then the teams are probably pretty well matched. I know that my solution was the yellow team won by 3/10 minutes. How do I know that this is reasonable? One is I can think about the context of the problem. We're talking about a swim meet, a swim medley, where we have two teams competing. This difference of 3/10 of a minute is very little. The teams were pretty close together. That makes sense for a race. I would expect that the teams' times were very close. If I got an answer that was several minutes apart, I might be wondering if this was truly a swim meet where the teams are competing neck to neck. Another way to verify if my answer is reasonable is to compare it to an estimation. I didn't estimate before I started. I just plunged into the work. But at this point in the board, it's okay for me to step back and reevaluate everything that I did. I know that I had Lorraine, Robert, and Pamela on the green team. I'm going to estimate their times just to the nearest whole minute. Lorraine had a time of 6 minutes. Robert had a time of about 7 minutes. Pamela, she had a time of about 7 minutes as well. When I add up, this is the green team, when I add up those times, 7 and 7 is 14, and 6 more, 20 minutes. Now I'm going to look at the yellow team. I had Yanira on the yellow team, Leon and Kim. Yanira, let me write yellow there. Yanira's time was about 6 minutes. Leon's time was about 8 minutes. And Kim's time was about 6 minutes. When I add up these times, 6 and 6 is 12, and 8 more is 20 minutes. Had I taken the time at the beginning to estimate, I would have said, well, geez, it looks like the teams finished at the exact same time. Well, now I ask myself, is my answer reasonable? I think that it is. When I estimated to the nearest whole, the times that the teams took were identical. This means that an answer very, very close to 0 as the difference between those times is also reasonable. This concludes me solving a problem from our Mathematics Problem Solving Journal using the Mathematics Problem Solving Board. To recap a couple of things, I want you to know that my work was done at a relatively advanced level. I used high academic vocabulary, I had complete sentences. I believe that what I showed was an exemplar of how to fill out the board. Students' responses may be different than mine, but the key is to look at their thinking. When they're rephrasing the question in a statement form, do they understand what the question is asking? When they're formulating a plan or strategy, do the students break apart the problem into steps that are easy to follow? When students justify their solution, do they prove that they know their answer is correct? This could look like what I did in the video, subtracting or adding to prove my subtraction or addition, or it could look like solving the problem using a different method and determining the same solution. When students evaluate their problem-solving process, do they think about their efficiency at solving the problem and how effective it was compared to other students? And finally, do students think about if their answer was actually reasonable for the given context? Do they compare their answer back to an estimation or take an estimation at the end if they forgot to do so in order to verify and justify that their answer is in the correct ballpark for what the question's asking for? We appreciate you taking the time to watch this video, and we hope that it helps you in your classroom as you continue to use the Mathematics Problem Solving Board with your students.